Hey, if you're watching this video, there's a pretty good chance that you're into Handmade Hero. You've probably been following along with the series, and you're most likely in kind of the same boat that I was in. So Casey starts the series off with developing on a PC. And if you've already got a Windows PC, that's certainly an excellent thing, wonderful resource to start with the Windows platform layer. But some of you are going to be like me, and you've actually got a Mac, and you want to figure out how to get started with Handmade Hero without having to go and buy a PC. So this is for people who want to just jump right into it straight from their Mac and understand how to actually build the OS X platform layer for the game without actually going and doing anything on a PC. So my name is Ted Bendixson, and I will be presenting this. So I've done most of the research for this myself. I've also used quite a few repositories in the process of getting this little series together. My aim for it is to just fill in that gap. So I know at some point Casey is actually going to build the Mac OS X platform layer in its completion. But what I want is to give people on the Mac some kind of a starting point. So you can actually start right here and progress all the way to the completed project. So it'll at some point, I haven't actually I've been writing the tutorials before I actually do them. At some point, you'll actually be able to connect right up where Casey leaves off. So that's my goal. I kind of think I'll know when this is naturally has reached its completion, just because there won't be much more to do. It'll just be following. But I've been following along with his tutorials and kind of doing one of these for each of them. So if you have followed along with Casey's tutorials, I suppose I should get a little bit into why I'm kind of doing this. I've been kind of interested in the handmade community. My background is primarily in iOS development, so mobile applications in Objective-C and Swift. I've also done Android development, and so for me, what I've really wanted is actually a project that is like the polar opposite of what I view as kind of like the trends, that the way the winds of change, or like the way things are going. And it seems like much of the way mobile development is going right now is almost in this web direction. It's in this kind of Node.js, React Native, cross-platform. I'm anyone that does these things, like this, obviously like a business decision, and I've certainly been on projects where we've been able to get prototypes out faster with those, but I would be lying to myself if I didn't say that on some level, as a developer, it feels like rather dissatisfying to work with these technologies. And I think the reason that it is, even if we are hitting business goals, or we're delivering really fast, speed being the operative word, you don't feel like much of an engineer. Actually, you feel more like you're kind of just wiring like things together, and it's this enormous stack that you don't really understand, and that whenever something like React Native, like it just you build it and then it like breaks, and you spend hours chasing after something, and this is you probably spend half your time just fixing stuff that you don't understand, that broke, that should just be working right away. And so I've been doing this entirely in my spare time, and I've been just thinking okay, what's the polar opposite of this? What is just the complete opposite of before we even get started, we have to download all this crap from Node, and we've got to have all these frameworks and packages and all this crap, right? And I'm not completely dogging on it. It makes a living. I definitely get paid well to use these things, and in some cases they have delivered a business result, but I think there's something better. And part of doing the polar opposite of that is getting at, and I think this is where Casey's going, I think this is where John's going, I think this is where a lot of people are going that I respect, is what is the polar opposite of all this, stack of web stuff that we don't understand, and can we make something cross-platform? Can we make something great with some simple tools that we actually really do understand? And maybe we can do it faster even. Maybe we can even get to a ship date faster. I obviously I recognize that an app is not the same product as a game. With a game, you're dealing with something very different because, frankly, the actual platform code for OS 10, as you'll see, is actually going to be relatively thin. It's a very small amount of actual OS 10 code that we're going to be using. Whereas you maybe compare that with a mobile app, you're probably going to be dealing with a lot more platform code, and so I'm not sure that the analogy completely fits. That said, to me personally, it's kind of refreshing to actually peel away all the layers and let's get as basic as possible. And so with that in mind, and starting off with the first episode of this, what we want to do is we want to set up a build system for Handmade Hero. And on a Mac, it's actually strikingly similar to what you would do on a PC. And we're going to be using the command line to do this. So you see part of my desktop. The rest is kind of occluded because if I record the entire screen, then my voice doesn't sync up to it, so I get a smaller section of the screen that's actually recording. But what we want to do is we're going to be using the terminal to do most of our navigation. I also let's kind of go over some of the tools that you want to get started on a Mac. Generally speaking, the thing that you're going to want to do is get xcode. So I've got xcode running here. You can get xcode from the Mac App Store. So I'm actually going to the Mac App Store right now, and you can see. So there it is. And so if I type xcode, you'll find xcode. So you just find xcode there. You download it. If you get the command line tools as well as xcode, that's really what you're going to want here. So command line tools are what allow you to use the compiler that we're going to be using to build this. We will be using Clang. And what Clang allows us to do is it allows us to build Objective-C, C++, C together, and Objective-C++, which is actually just a kind of a combination of them. That's what actually allows us to build the game as it would be on a Mac. And remember, the actual game source is going to be in C and C++, but the Mac platform layer will be in Objective-C. And I know some people will say, could you do it in Swift? I really like Swift. I actually really like Swift as well. I think it's an excellent programming language. Kind of getting closer to what we want out of this, but you certainly can. I just think that this actual platform layer is going to be so thin that it probably wouldn't be worth the endeavor. Maybe we can revisit it at some point, but we're really literally talking about something like we want a basic entry point, a main function. We want a simple window and a buffer that we can write to. And maybe some sound processing, maybe a few other things, but we're looking at something relatively simple in terms of what's actually going to be a platform code. So getting into some of these languages, so obviously Objective-C is what we're going to be using for the platform layer, and Objective-C has been around for a long time. It's actually been around since Steve Jobs came back from came to Next Step from Apple. So that's kind of why you get these. It was developed at Next Step. That's kind of the company they started after Apple, and that's why you get this like NS everything. So NS strings and NS this, NS that. It all comes from Next Step, and so that's really where I got started. And then all this obviously got brought into the fold at Apple. So that's what we'll be using to actually build the app. So just know we've got a blank desktop now, starting completely from scratch. First thing we want to do is open up a terminal window. There's a lot of different ways that you can open up a terminal window on a Mac. I actually have it in the taskbar, so you see now the screen is kind of covered. You can't really see my face, but yeah, so I've got this little terminal window here, and you can actually open up the terminal a lot of different ways. So you can do it from Spotlight. So I've got a Spotlight search, and I just go terminal, and I should find it. You can also do it from the the launch pad. So a few options here. You can see I was running some things here. So I'll actually just start a fresh window. Sorry if some of this stuff isn't completely lined up. My recording window is not the same as the entire screen, so I kind of have to manage this. So this terminal window kind of harkens back to the old days. This is how we actually used to do things. What we're looking at here is I'm starting off in my basic directory, kind of my home directory, and I can type a few different commands to sort of see where I am. So ls will actually list the directory contents of where I am. You see I've got a few different things. If I wanted to say switch into my app development directory, I would type cd, which means change directory. So development. So another important thing when you do this is make sure that it's enclosed in quotes, because if it's not, then you'll get an error. So it won't recognize it as a directory. So just make sure it's enclosed in quotes. So now we actually are seeing what's in the app development directory. And if we wanted to go back, we could do change directory .. And what that's going to do is just move us back to where we started. So that's kind of useful. In this case, let's just say we wanted to make this project from the very beginning directory in just wherever we started. So you mkdir, and let's just call it Handmade Hero. And that will make a directory called Handmade Hero. And then if I list it, you can see that it's in there somewhere. So, yep, so then I go cd Handmade Hero. And now we're in our Handmade Hero directory. Pretty cool. Just kind of to get the directory structure kind of going, we'll make a few different directories. So let's make another one. Just call it Handmade. So this Handmade directory inside of here will actually contain all of our, that's going to contain code and assets and that kind of stuff. So then we can change directory into Handmade as well, and then there's nothing there, duh. Then we can make another directory just for the code, and then go into there. And so obviously you wouldn't see anything in there. But now if I open up my Finder window, so if I open up my Finder, then we can see Handmade Hero, and then we can see the Handmade directory, and then we can see the code directory. So we've got kind of a basic setup here that we want, and that's just kind of some simple navigating around the terminal. You don't really need to know too much here. We'll be using the terminal obviously in order to build the actual project. So this is where we'll kind of be running our build script. But now what we want to do is actually use xcode to create a file. So I have xcode open, and I'm actually you can't see it right now because it's off the screen. But you want to go into the File menu and then go New File, and I'll move this window over here so you can see. So Xcode is going to give you kind of like a litany of different possible things that you could choose here. And frankly, you know, these are great when you're doing like iOS projects or macOS projects. But for something like this, we're not using any of them, so we're just going to actually just use an empty file. Just about as bare bones as it gets. And the naming of it is actually really important here. So I call it OSX main.mm. And this, so OSX main is just saying this is kind of the main entry point into the OS 10 platform layer. I sort of got that naming convention from Jeff Buck's repository. And then the .mm, all that means is that this is what's called an Objective-C++. So there's Apple's programming language Objective-C, and that's going to be like the pure platform layer that we're going to be using for Mac. But then there's also Objective-C++, and there's nothing. It's not like a new language or anything. Like this is nothing super fancy. But what it is it's just mixing Objective-C and C++ in the same file. So if we were to do that, then we would, you know, that's calling it a .mm is just mixing Objective-C and C++. So we will do that and create it. And now we just, you know, we've got a nice kind of blank window here to work with. So, you know, you can obviously comment and say, oh, it's my main, you know, the main entry point to a Handmade Hero. Okay, so what do you want in this file? Well, as it turns out, there is a C function that if you put it in a file and if you compile with clang, then the operating system will know that this is the main entry point into your application. And it is where everything in your application will start. It will allow you to build it. And that particular function is int main. And then you want int argc, and then constant char star argv. And you've probably seen this before because it's pretty much, you know, it's the same thing in a lot of different systems. I think it's the same. It is the same in Casey's as well. So this is the main entry point into our application. And if we were to just write this and save it and compile it, we would get an app that runs. This doesn't really do anything though, so it would be very difficult for you to like tell if you were successful or not, or anything to that degree. So just because, you know, I think it's kind of nice to have it actually do something. We'll just say Handmade Hero ran successfully. Just so you get a little bit of feedback. Now this printf function, you've probably seen it if you've done C++ or anything like that, or C. That's just, it'll just print something to the console, to terminal when we run it. But we actually need to import something in order to, we need to import the standard IO library in order to actually do anything with this. So we'll do that. So we'll import standard IO. And now we've got something that we could compile and something where we could actually see what it does. So I'm in terminal, and if I ls this, ooh, that's not good. That wasn't saved where I wanted it to be saved. Okay, hang on just a second. Shoot. Okay. Not to worry. Man, I'm just, where is this? Hang on, I'll just move it. I've got like a million of these from all the other tutorials. So, but you want to save it there. You want to save it in your directory. So Anyway, all right. Okay, and save that in our Handmade Hero directory. Okay, so now if I do an ls, you can see that our OS 10 main file is there, and we're good to go. How do we make an app out of this? Well, interestingly enough, all we have to do is just type clang -o handmade. And so -o actually means like this is the output. So this is what we're going to call this is what we're going to name the output file. So it's called handmade. And then after that, we want to tell Clang what do we want, which actual file do we want it to compile. So we're going to call it os10 main.nm. That's the file that we just made. So it's going to spit out a thing called handmade, and it's going to compile osx main.mm. And if we did everything right, we shouldn't see anything. And if we we can actually see our executable. So we can just go back in the Finder window, and you know, it's a standard Unix executable. You can just like double click the thing. Sorry, the window doesn't appear right away, but basically, like you just get a terminal window and it says Handmade Hero finish running, and you're done. So obviously, like not the most exciting application. We definitely want to be doing much more with this, but it's a pretty good start, I would say. So we have a very simple way to we understand what kind of file we're making, and we also understand how to actually run the compile command. One thing that we probably don't like about this, if we look at the way this is done, we're kind of mixing our code and our executables, and it's not the most organized way of doing things. So, and this is kind of something that Casey mentions as well, is if we've really got all this stuff just kind of like in the same spot, like that's just that's not going to be good. What we want is like a nice clean separation between our build, the result of a build, the product itself, and the code that makes the product. So that means we need to set up some kind of a build system. And if you have been in Xcode recently, you know, I'll just give you an example of a project that I myself work on. So I'll try and fit as much of this into here as I can, because I know you can't see my face and all that. Anyway, so here's one of my projects that I work on. This is actually one of my own iPhone apps. Let's see. This is my random snowboarding trick app. So if you snowboard, you know, this is the source code. It comes up with a random trick to try in the terrain park. I jump a bunch. So this is kind of like my thing I made for myself so I could try new tricks. Anyway, what you're probably used to is something like a project. And you're probably used to seeing build settings here, right? And you're probably used to this kind of build button there. And this works, you know, you've got all these build settings here as well. So you just got this like litany of, you know, all these different possible architectures that you could run on, and et cetera, et cetera, et cetera. And it gets to be quite a bit to manage, I would say. And the thing is, you're always, you know, if you start off as a Mac developer or an iOS developer, you just like run right at you just start off like this, like in this kind of complicated, and you don't actually, you know, like understand that, you know, at the very bottom of this is like there's, you know, some script that's like running a clang command, or you know, that it's outputting some kind of an executable. And so we're actually going to be making our build process completely from scratch as well, and not simply relying on an xcode project file, as one would typically be used to doing. So we can do this, though. This is actually not that difficult, and it turns out that that we can do it in a very similar way to what Casey does. If you look at Jeff Buck's repository for this, he uses a makefile, and a makefile is certainly great. I'm a fan of it, but probably not as simple and probably not as much in the spirit of this particular series as just, let's just like put together some commands. And Casey does a bat file, and I know everybody kind of oh, this is like blasphemy to just put everything in a single batch file, but I like that it's so simple. I like that it's actually just this, like, I can see everything that it's doing, and it's just this, like, here's the commands that are actually getting run as a part of the build. And perhaps, since we're doing this with minimal dependencies, maybe it won't be such a, maybe not having to, maybe like building everything over again every time, and not managing like what's been partially built and what's not and what changed and all that stuff. Maybe the like lower amount of complexity will actually give us some fairly fast builds as well. So that's kind of my hope with this, is maybe it actually only takes a few seconds anyway. So this part is surprisingly similar to what you see in the first day of Handmade Hero. So a bat file or a batch file is kind of the Windows equivalent of a shell script. And on OS 10, we can actually make a shell script of our own if we want to. And all that we would do is, I'm going to use Vim to do this. So there definitely is an xcode way. It's actually in the article that I wrote. And to do it the xcode way, you just create a new file, and then you there's actually there's a little template for a shell script. You could even do it with a blank file if you name it, if you just give it a .sh extension. All that Apple's template's doing for you is putting a .sh extension there, so it's really not like, this is just, it's a text, you could use TextEdit or, something like that. So it's just a text file. So you're going to do, just type Vim and then the name of the file that you want to make. In this case, we'll just call it build.sh. And so if you've never used Vim before, it's pretty cool. I'm kind of new to Vim. I like this idea of, and at first, like, I think I worked with somebody that used it before. I was like, why would you use that? Like, that is so old school, and xcode completes everything for you. But what's so cool about this, like what I'm really have grown to appreciate, is like, if I'm using it properly, which I'm not yet because I am like still quite noobish to this, my hands don't leave the home row. Like, this is freaking awesome. Like, not having to go over to it. It feels so ergonomic. It actually feels like so very satisfying to be able to kind of jump around the text without having to you almost forget like how distracting it is to have to move your hand over to the mouse every time, and like how much it kind of breaks your flow. Like, this is cool because everything can be done from the keyboard. So if you're in Vim, which some of you have maybe been thrown into Vim before, a lot of times it happens like when you're doing GitHub or Git from the command line, and you'll be like doing some operation, and then like it throws you into Vim, and you're like, how? This is why you see on Stack Overflow all these threads like, how do I quit Vim? Because like somebody got thrown in here, didn't know what they were doing. Really, it's actually not that difficult. It's fairly simple. So in this case, we're kind of in command mode. Because it's a blank file, there really isn't much we can do. But if I hit I, that puts me into insert mode. And insert mode is kind of everything you're used to with typing in a document. So I can type something like, build.sh, the build system, or maybe I'll just, do the build system for Handmade Hero. Okay, and so you see those little tilde things. That's just like, space that's just a way of denoting that they're that it's like space that doesn't exist. It's not part of the file, and all the stuff above it is actual space that is part of the file. And so those are, space is a character, so it's just denoting the difference between what it really considers a space and what's actually not a part of the file. So this is, you can imagine this sh script is actually like, it's as if we're in the terminal and we're going to give it a series of different commands. And it's going to run all of those commands in succession just as a script. It's just a straight up, on PC it's called a batch file because it's just a batch of stuff that we're going to like run. So the first thing we want to do, and this is pretty much, if you were to go to Casey's tutorial, it's like the same as this. So there's no difference here. It's literally, you could copy, I think you could copy the bat file like 100% verbatim if you wanted to, and you would achieve the same result. But just because I enjoy hearing myself talk, I will actually go through it. And so the first thing we want to do is we want to make some kind of directory that represents where the product is going to go, and we would call that the build directory. So we're using what is known as relative paths. So for file paths, we're actually not, this would be contrasted with like an absolute path, saying this particular starting point and then all the files and folders to get where you want to go. This is assuming that we are in a particular folder in the project and everything that we're doing is actually relative to that folder. So because we want to run the build script from the code folder where all the code is, we're assuming that we've started in the code folder. Okay, so everything that we're doing, we're kind of assuming is there. So the first thing we want to do is like make our build directory. So we do mkdir, and if I just said build, that probably wouldn't work because we don't want the build directory to be in the code directory, right? Like we want it nice and clean and separated. So I think it makes a lot more sense to do something like navigate one directory up. So if we look at this a little bit more closely, here's the code, right? And then if we navigate from here to here, now we're in this directory. We don't really. I don't think we want to. I don't think we quite want to go there. I think we actually want to go one up, so it's completely out of the handmade directory, and it's like next to it. So remember that to navigate to the parent directory is just .. and then so depending on how many times we do that, we're going to go back up the folder hierarchy. So .. build. Okay, so now this makes the build directory that we're going to be storing the product in. And you may have seen these particular commands, push D and pop D. So all this is doing is it's directory navigation. So push D just means push a directory, and pop D means pop a directory. If you've done some computer science work and are used to this concept of a stack, it's very much like that. So I'm pushing a directory that I'm going to navigate onto the stack, which means I'm going there. And then I'm going to pop, I'm going to like go back to where I came from. So we made a build directory. We're going to go to the build directory. Then we're going to run the compile command from the build directory. And then we're going to go back to where we came from, which is always the code directory. So in this case, we just want to push D the same thing. Build. Okay. So what that's going to do is it's going to throw us into the build directory. And now in the build directory, this is where we're actually going to run our compile command. So clang -o. And this part of the compile command is actually going to be the same because this is the part that says here's what the name of the output's going to be. So the name of it is going to be Handmade. It's going to be in this directory. It's not going to be in any other directory. But what differs now that we're going to directory different, now that we're not in the code directory anymore, what we decide to compile is located somewhere else. It's in a different directory. So we have to kind of navigate to that OSX main file in order to actually build it, right? So we have to find that file. And it's all relative. We can't give it an absolute path. Otherwise, this isn't going to work on anyone's computer. It would only work on like the specific computer that it's on. So we look at this. Our build directory is going to be here. One directory up will be where my cursor is, and then another. Then we would go into Handmade, and then we would go into Code, and then we would find OSX main. So it's going to be something like /handmade/code /osx main.mm. Okay, so that's gonna do that's gonna look, it's the same command. It's just that now we're kind of formalizing. Make this directory, go there, build it from here. Build that code and put the result in this file. Okay. So if you look at my Vim console, it still says we're in insert mode, and that's fine. If we hit escape, remember it's like a modal text editor. So if I hit escape, then now I'm not in a text editing mode, and I'm actually in a kind of a navigation mode. Kind of like some of the really cool stuff with Vim is you can do all of the navigation around your document from the home row on your keyboard. So there's no actual there's no need to jump to a mouse, or even like you can still use the arrow keys, like I'm actually doing that right now to move around, but there's actually no need to do that. You can use like H, J, K, and L to kind of move the cursor around. Another kind of cool thing you can do in Vim is like if I hit W, it actually goes to the next word kind of a chunk. And so like everything you can do here is actually completely possible from the keyboard, which is really cool, really powerful. I can also search, so if I just search for like mkdir, that's the slash, then I hit return, my cursor will go to that location. Kind of cool. So that's kind of the navigation mode. That's really the default mode. And then if you ever like want to go back into text insertion mode, you hit I, and then you can kind of insert text. But we want to quit Vim, and we want to save this result, right? So this is the answer that you get when you ask, like, Stack Overflow, how do I quit Vim? I just hit the colon. So colon puts us into command mode, and in command mode, I want to do a few things. The first thing I want to do is W, which is write, and then the next thing I want to do is Q, quit. So all I'm saying is here's two commands, write and quit. And then I hit enter. And so what did that do? It wrote and it quit. And if I do a list the contents of this directory, I see that I have my build.sh, and I see that I have my osx main.mm. And now I can run it. So I just type sh build.sh. Okay. And interesting. Oh, wait. I don't think commands. Oh, okay. So those, I forgot that. All right, let's go back into that. This is kind of funny. Comments don't really work the same way in a shell script. I have a different shell script somewhere. That is so funny. I had not really realized that. I actually am just kind of curious now because I want to see the default Apple way of doing it. I think they've got a different. Okay, so here it is from like. Oh no, wait, that's a different one. Shoot, I've got so many of these going right now. Okay, here's the one I did. Yeah, I'm gonna get rid of the comments. We don't need them. So another great example of what you can do in Vim. If I want to delete a word, I type DW, 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 DW. Okay, so that's pretty cool. And then another cool thing you can do is just DD. that just deletes like a line, so a line at a time. And we don't need any of this other, like we don't need any of these other lines. And then I hit colon, and you can do WQ, that definitely works, but they actually gave you another command that kind of puts them together. So X is a WQ. And now if I do sh build.sh, okay, now I'm not getting the it interpreted my comments as commands basically and said, oh, that's a directory. Yeah, // is a directory. Okay, we don't want that. So now we want to go back to our build directory. And we know we can get there because it's .. / build, right? Change directory. And we've got Handmade there. And actually what I want to do is just show you, okay, so getting all the way back to this. So we have our Handmade and our code folder, and we've got OSX main and build.sh. But we've also got this build folder, and that is where our game has been output to. And we also see this Handmade Hero finished running. So that's the same thing we've been building. It's all there. Very good. Excellent. So at this point, we've actually got a build system that we can work with. And one more important thing, though, that is actually missing from our project, from our build system, we have it where it's building the executable. But I think that you'll agree with me. One of the things we're definitely going to want is like some way to debug this thing. Because if we can't debug it, like we're just screwed. It's just not going to be possible. I think at some later point I will probably integrate xcode debugging with this. I have not yet figured out how to debug with xcode without all the other hefty project file and all this other stuff. I'm sure there's a way to do it. I just haven't done it yet. So we're going to do it from the command line. And debugging from the command line. So this is like super old school. We'll be using LLDB for this. And in order to debug from the command line, we need to actually give it some symbols that it can use to debug. So in this case, I'm back here at our build file, and I'm just going to vim it. And you can use xcode. Like don't feel like don't be a hero. If you don't want to vim this. So I'll just go /-o, and all that does is it just navigates me to the place where I'll probably want to be inserting my text, and then I to insert, and then -g. Okay, and so all -g does is it says like give me some debug symbols along with this. So when we build it, we'll actually get the dsym file, and all the dsym files is like desymbolicating, meaning that we will get, the debugger will get method names and lines and all this stuff that it can insert breakpoints into and step through the code, which we want. So I hit :x to save that, and then I go sh build.sh. And now the only difference is here is that when we go back to our build folder / build, we will see this handmade dsym file, and so that's actually what the debugger is going to be able to use for debugging. Now we can definitely start the debugger. We would want to know where we're going to put that breakpoint. So to start the debugger, you just go LLDB, and then you pick the name of the target, the executable that you want to run. So we will call ours Handmade because we are in that folder. We're in the build folder. Okay, so LLDB has like attached itself to Handmade, but we want to set a breakpoint. So what I'm going to do is just in a separate terminal window. In a separate terminal window, I'm going to go and just actually, you know what? I don't want to do that. I forget how to get lines. All I want to do is like know what line where our print command is at, because we want to we want to put a breakpoint there. Okay, so it's line 9. So we'll put a breakpoint at line 9. So to do that, you go breakpoint set osx main dot mm -- line 9. And so the one thing that's kind of important to know is, like, remember earlier when we built from the, because we were technically kind of in the build directory, earlier when we built from that build directory, we had to like specify the path to get to osx main.mm. So why is it that I'm able to actually like not have to do that anymore? Well, the reason is because of our dsym file. That dsym is what allows me to just like reference this particular file, which was included in the bundle and in the debug symbols that got got added. So I can actually just reference like the file name itself when I'm making a breakpoint. Okay, and so now we'll see that we have a breakpoint in our this kind of that we can run into. So what's going to happen is we're going to run the debugger, and it's going to stop at the breakpoint, and we'll be able to kind of inspect some stuff and move around and see what's going on. So to start the app in debug mode, we just go process launch and hit enter. And it's kind of neat. Actually, you know, it's kind of cool to be able to see this like right from the command line. And I've got this, this is where we stopped. A little arrow tells me we stopped here. And, you know, we can do things now in the debugger. So usually if you're on an xcode project or like a iOS app or a Mac app or something like that, you're probably used to something like looking at the different variables just to see, you know, what's the contents of that variable. And that's definitely something you can do. Here though, we don't really have any variables. We've just got this one print statement. So I thought it would be kind of cool to ask a better question or just some question like, you know, and this is something kind of Casey goes into as well. You know, presumably, so we know what our app's entry point is. Like, we know that that this main function that we wrote, you know, int main, is the entry point into the application. So at some point, the Mac OS calls into that function. At some point, it does that, and but the question is like, what library in Mac OS does that? How does the operating system go about that? Like, it's this who called us, right? So somebody called us, right? But some function called, it had to, right? Some function had to call us. Who called us? And it's kind of a good question. The debugger actually gives you a nice way to answer that question. So we can see which threads are running by just going thread list. So we have one thread, and it's this one right here. That doesn't really give us much information, but what will give us some information is seeing what the stack frames look like. So seeing like if you know, functions are kind of like managed in a stack, and the idea is like when a function is in the middle of executing, we need to be able to return back to that. So it turns out a stack is actually like a really good way of doing it. So our caller is like, you know, it's weird with the camera being this way. It's actually on the bottom, and then there's something on the top. Okay, and so our function is like on the top of that, and when our function is done running, we're gonna like pop off of that, pop off the stack, and then now we're in the function that called us, and then eventually it's gonna pop off, or it's gonna finish running. So the question is, you know, what's kind of underneath the stack from where we are, and to get that, we go thread backtrace. That's the command. Okay, cool. So we've actually got some interesting things here. So we've got frame 0 is kind of where we are at this line, but then we've also got this other frame here, this libdyld.dynamic library. And that's kind of interesting because I think that's actually who called us. So what that's saying is this is actually where the operating system called us. libdyld.dynamic library start. This is actually, if you look it up, I actually spent a little bit of time just kind of researching it. It's it's Apple's one of their main libraries in OS X. If you don't, if this library didn't exist, basically OS X would be nothing but a kernel, and you wouldn't be able to run any kind of consumer application or any stuff that you're used to at all without it. It manages the loading of dynamic libraries and all this other kind of setup work before finally calling into your app's main function, which is where we are. So that's kind of cool. We can actually see what called us from the very start of the application. And this is sort of getting down to, more of like the foundation, right? Because typically when we're dealing with Mac apps or if you're an iOS developer like me, you don't usually get to see this far down. Usually the main function is generally hidden off in some file that if you start an app from scratch with the Swift project template, you can't even find the main. There is no like main function, and so you wouldn't even know where it is. You wouldn't even know that it exists. But even if you can see the main function, much of what's actually getting done is hidden inside of other things. So it's hidden inside of this UI application main or NS application main class that is kind of hiding the bulk of the work from you. Maybe that's just kind of Apple's way of doing things, like that's their style. I don't know, but anyway, so we're to finish out this process, we just go process continue, and so all that's going to do is it's going to continue the process from our breakpoint, and in that case, if we do that, then we're going to see our print message, right? So we stopped at the line right before that happened, and then we get process exited. Okay, and so this is a really important thing to know about our. If we go back to this, let's you can hit Q to exit LLDB. Oops. CD / handmade / code. And then if we go vim osx main.mm, you don't have to use vim. You can if you want. So this is the important thing to know right here. When we get to the end of this function, the app quits. Like it's done. It ends, right? And most of us who build OS X apps or iOS apps from scratch, or not from scratch, but from the project templates, we never see this. We don't actually know that, unless you kind of dig into it, you don't know that somewhere in these lines of code right here, something's got to keep the app running, right? Like something has to. This thing can't just it can't just run and quit, right? And you don't see where that code is on your typical iOS app or Mac OS app because it's hidden inside of this inside of a class called UI application main or NS application main. And what those classes actually do under the hood. So like the only way that we can keep this thing running without exiting immediately is some kind of an infinite loop. Like I think you'll agree that that's necessary. Like that's just kind of a logical conclusion from where we are. If we don't have an infinite loop, then it's just going to process all the shit and like we're done. So we need an infinite loop of some kind, and that's kind of what we'll go into the next actual video. And the article's already up for this, but the idea is we need to make a run loop. A run loop is just an infinite loop of some kind that continues to run while the application is running. And what happens when you decide to quit an application, like you press the little X in the window or you leave the application, all that's going on is something is bailing out of an infinite loop that's in this main function. It's quitting out of that loop, and then it's allowing the main function to resume its execution and get to the very end and then return. And it returns to libdyld.dylib, the OS X function that called us, and your app quits. That's all that's going on, is it's bailing out of this run loop. So it's just kind of cool to actually be able to see this happening, you know, completely from scratch, because you usually wouldn't get a window into this if you did everything starting with a project template. So that is that's this particular video for day one. Right now we are actually at the end of day one, as it is in Casey's video series. What I'm trying to do is really follow it as closely as possible. I'm gonna say definitely give Casey your support. Go and buy Handmade Hero. I spent 15 bucks on it. I don't even care if I get a game or not. I'm sure I will. But I think it's so important to support Casey and the work that he's doing, because there's like literally nothing like this anywhere on the internet. There's nothing like it. I mean, what we've got right now is kind of a lot of cobbling of stuff together, and I'm going to show you this framework of the month, and you know, here's your React Native and your Flutter and your, you know, everybody wants to build something that's like simple and easy and fast, but very rarely do you see something where we're building it, and on top of that, we're getting a real understanding of what's going on. Like we know it all the way down to the freaking atoms. You rarely ever see that, and I think it's cool. I think it probably doesn't need your support at this point, but it deserves your support. Like, great work deserves your support. So anyway, with that said, I will see you next time.